Earth, the only known planet to host life, the third planet in our solar system, the pale blue dot seen by the Voyager 1, the Mother Earth we all live on. But the origin of Earth is a tale written in rocks, a story that unfolds through eons of time and layers of geological history. As we delve into the heart of our planet, we embark on a journey that spans billions of years, from the fiery birth of Earth to intricate tapestry of its layered structure. Approximately 4.6 billion years ago, our solar system was a swirling mass of cosmic dust and gas within the cosmic chaos. A process of accretion gave rise to the nascent Earth. Under the influence of gravity, particles collided and merged, forming a growing sphere that would become our home. It is said that about 99.8% of mass was concentrated within protosun. After a period of some tens of millions of years only, density and temperature within the sun's interior had reached critical limits and nuclear process started. Due to decreasing rotation energy towards the outer part of disk vortices formed and supported accretion of numerous small bodies called planetesimals. The gravitational forces of all these bodies attracted more and more material. Irregular orbits caused multiple collisions. In this way, the number of planets decreased, but their size increased, and they rapidly grew in their size. A defining moment in Earth's early history occurred when a mass-sized object called Theia collided with Earth about 60 million years after the solar system began to form. The type and the composition of the sample showed that the moon was molten during its formation and was covered with a deep ocean of magma. For tens of millions to hundreds of millions of years, an environment that would occur in the aftermath of an intensely energetic impact was seen on the moon. Occurring between about 4.6 billion years to 4 billion years ago, Hadean Eon is characterized by Earth's initial formation, from the accretion of dust and gases and the frequent collision of larger planetesimals, by stabilization of its core and crust development of its atmosphere and oceans. Throughout this eon, impact from extraterrestrial bodies released enormous amounts of heat that likely prevented much of the rock from solidifying at the surface. The name of this eon is derived from Greek translation of Hebrew word Hades, which means hell. Earth's surface was incredibly unstable during this early part of Hadean Eon. Convection currents in the mantle brought molten rock to the surface and caused cooling rock to descend into magmatic seas. Heavier elements such as iron descended to become the core, whereas lighter elements such as silicon rose and became incorporated into the growing crust. About 4.4 billion years ago, continents became stable with liquid water forming, and surface temperatures were probably less than 100 degrees Celsius or 212 degrees Fahrenheit. Due to movement of tectonic plates, original crust has been subducted, and thus few rocks and minerals remains from this interval. The oldest known rocks of this time interval known are Fox amphibolite volcanic deposits of Nova Schutt, Greenstone Belt in Quebec, Canada, which are estimated to be around 4.2 billion years old. As planets age and cool off, their internal and surface processes gradually change. Manifestation of changes within the Earth's interior, such as development of mountains and volcanoes, have a huge influence on the nature of Earth's surface and atmosphere. Scientists know that much of the rock in Earth's mantle, which is under extreme pressure and very high temperature, behaves like a viscous liquid. This vast interior, however, is largely inaccessible to direct study. For over a century, seismic waves, geomagnetic and gravity measurements made at the surface have been improving understanding of Earth's internal structure. Scientists are only beginning to explore the connections between Earth's core, magnetic field, mantle, and the surface, and to investigate why Earth differs from different planets or how it may change in the future. As the Earth cooled off, the process of differentiation began. Heavier elements such as iron and nickel sank towards the center, forming the dense metallic core. Simultaneously, lighter material rose to the surface, creating the early crust. This phase marked the genesis of Earth's distinctive layers, the core, the mantle, and the crust. The core. At the heart of our planet lies the innermost layer, the core, comprising a solid inner core and a molten outer core. This region is predominantly composed of iron and nickel. The intense heat generated by radioactive decay and residual heat from the planet's formation maintains the molten state, driving the dynamic processes that shape Earth's magnetic field. The mantle. Above the core extends the mantle, a vast reservoir of semi-solid rock that exhibits slow but continuous motion. The mantle convective currents play a crucial role in the movement of tectonic plates, shaping the surface of our planet. From the uppermost layer of mantle, magma occasionally breaches the surface, giving rise to volcanic activity and the creation of new crust. The crust. The outermost layer, the crust, is where life as we know it flourishes. Composed of solid rock, the crust is divided into tectonic plates that drift and collide, resulting in the sculpting of continents and the creation of geological features. The crust is a testament to Earth's ever-changing visage shaped by processes spanning vast stretch of time. The interplay between Earth's layer is the dance of dynamic forces. Tectonic plates that moves, volcanic activity, and seismic events continuously reshape the planet's surface. The layers not only define the physical structure but also influence the distribution of resources, the climate, and the evolution of life. A major focus of Earth science has been on deciphering the nature of continents, the features that make Earth habitable for land-dwelling life. How and when did the continent form? How have they changed? Why do the Atlantic coastlines of South America and Africa look like the piece of a puzzle? What are plate tectonics? What are sea plates and land plates? What are supercontinents? Let's decipher the answer for these questions in our next video.